Welcome to ASU's University Academic Success Programs. This video will cover the topic, Electron Energies.
What's the importance of the energy of electrons?
Atoms exchange or share electrons, which results in chemical bonding. Ultimately, electrons want to have the lowest amount of energy possible. And when electrons are in a bond, they are lower in energy. This is because electrons are negatively charged, and electrons in bonds are stabilized by two positively charged nuclei rather than one. For example, if we take a look at a hydrogen atom with one electron, and compare it to two hydrogen atoms with two electrons in a bond, we see that the electrons in a bond are lower in energy than the electron that's not in a bond. When we look at this concept, we can draw energy diagrams to represent the relative energy of electrons. On the left, we'll establish that energy increases as we move up the diagram. The lone electron is in an atomic orbital that is higher in energy than the molecular orbital that contains the bonded electrons, so we represent this lone electron positioned higher on the diagram than the two bonded electrons.
So then which of the two is more reactive?
If an electron is high in energy, this typically means it has high chemical potential energy, and as a result is more reactive. If an electron has the ability to participate in bonding, or form a stronger bond than the one it's in, it will do so in order to lower its energy. Since the lone electron is not yet in a bond and is higher in energy than the bonded electrons, it is more chemically reactive.
I think that makes sense. What other factors might influence electron energy?
When comparing electron energies, we can take electronegativity into account. Electronegativity is an atom's tendency to attract electrons. Let's take a look at the electrons in nitrogen compared to the electrons in fluorine. Fluorine is more electronegative because it has a higher positive charge on the nucleus and holds on to its electrons more tightly since they are more stabilized by the nucleus. This tells us that the electrons on fluorine are lower in energy than the electrons on nitrogen. Based on this information, we can establish the trend that as electronegativity increases, electron energy decreases. Another concept we should discuss is ionization potential. The ionization potential is the amount of energy required to remove the highest energy electron from an atom. Let's compare carbon and nitrogen. Since more electronegative elements hold onto their electrons more tightly, it's more difficult to remove an electron from a highly electronegative atom. Nitrogen is more electronegative than carbon, and therefore its electrons are lower in energy. This means more energy is required to remove the highest energy electron, and therefore nitrogen has the larger ionization potential.
Can we draw an energy diagram for this too?
We can. We see that the highest energy electron in nitrogen is lower in energy than the highest energy electron in carbon. If we say that the top of the diagram corresponds to the energy of an electron infinitely far away from a nucleus, then we can label the ionization potential as the amount of energy between the electron and the top of the diagram. Since the electron in nitrogen starts lower in energy, it has a larger ionization potential and requires more energy to remove. Here we see another trend. As electronegativity increases, ionization potential also increases.
So in looking at electron energies, electrons in a bond are both lower in energy and less reactive than non-bonded electrons. Also, we compare electron energies between atoms by looking at electronegativity. As electronegativity increases, electron energy decreases, and ionization potential increases.
That's exactly right. Great work!